Hello everyone, in this video we're going to be diving into memory in a little bit more detail. Now when it comes to interview questions, we don't have to have a deep understanding of memory, but we do need to have a high level overview. Some people represent memory like this rectangle, and they start off with the first memory slot 0 and 1, 2, 3 and so on. But in this video I'm going to use the grid format. Now it's the exact same way, but I feel it's a little bit easier to understand memory using the grid. In this video, this is the way that we're going to learn about memory. Now, our memory grid that I've drawn out can only hold 16 different bytes. And that's the first thing we're going to come to, is the word byte. So when we say byte, we can think of our memory addresses in terms of bytes. So if we had, let's say, a 32-bit integer or a 64-bit integer, we would say we need 4 different bytes for that 32-bit integer, or we would need 8 bytes for that 64-bit integer. So if we need 4 bytes, we need 4 memory addresses. For our example, we're going to just pick a random number. I'm going to pick the number 5. And when we work with variables in JavaScript or Java or C++ or whatever programming language that you want to use, we have to set variables. So imagine we have a variable called num, and our num variable is set to the number 5. You may know how the number 5 is represented in binary, or you may not. 5 in binary is equivalent to 1, 0, 1. So this number 5 has 3 different bits. Now, as I said before, each of these memory addresses hold 8 bits. So even though our number 5 only holds 3, there will be essentially 5 bits kind of wasted, but they need to be there. For example, if we wanted to change our num from 5 to 10, we would then need to go and allocate more memory. So this brings me on to my next point, which is if we use Java or C++ or C#, these integers that we define usually have a set amount of bytes. So as I said, if you're familiar with Java, there's a long in Java, and a long in Java takes an integer of size 64 bits. So we would need 8 bytes or 8 memory addresses. Now, if we were to use a normal int in Java, we would get away with just using 32 bits. For this example, we are going to store our number 5 in a 32-bit integer. Now, the first thing you might be thinking of is, okay, I've got a number 5, I want to store it in one of these memory locations. I know that I can't store it in just one single memory location like this, because we said we're using a 32-bit integer, so we'll need 4 different memory locations. Now, we also know that it's not represented like this. It's not represented as the number 5, because computers only understand ones and zeros. It only understands binary. So if we want to represent our number 5, we would do so by writing 0, 0, 0, 0, 0, 1, 0, 1. And this is essentially our number 5. Now, since we use a 32-bit integer, we have these other spaces as well. These are used up for the same num variable that we have up here. So these 3 memory addresses will just consist of all zeros. So this one here will have 8 zeros, this one here will have 8 zeros, and this one here will have 8 zeros. I'm not going to draw them all out, but you can see what it would look like. Now, another thing that you might be thinking of is, why did I start with the number 5 on the most left column? Should the number 5 not be over here and our zeros would be here? This is a possibility, and it depends on what way your CPU is architected. It depends on if it uses big endian or small endian, and this is referred to as endianness. So the way I've defined it here is using big endian. If you done it the opposite way around, it would be small endian. So just keep in mind that you can have it both ways, but in terms of coding interview questions, you won't be asked about things like this unless you're going for maybe a C or a C++ role that requires a lot of low-level understanding of the language. Now, for this example, we used a number and we stored the number 5, but If you come across characters, strings, or pointers in your programming languages, all these are stored in memory before they're executed by the CPU. So the memory is like a middleman between the CPU and the hard drive. The CPU doesn't want to directly access the hard drive because the hard drive is very slow. Even if it's an SSD and it's much faster than a hard drive, compared to memory, it's really slow. And memory compared to the CPU is super slow as well. So this is why we use memory to hold the data that we've been working on recently, and then our CPU can perform our operations at a very fast pace.